On this 2019 through 2024 Ram 1500 Classic with the 5.7L engine, P0013 is a PCM fault for the camshaft position actuator control circuit. In plain terms, the PCM is commanding the variable cam timing solenoid circuit and seeing an electrical state that does not line up with what it intended. The truck may turn the MIL on, and depending on the failure, it can have possible drivability or cam timing control complaints. For this code, think in broad electrical terms first: possible open or high resistance, short to ground, short to voltage, a ground side problem, connector issues, or the VCT solenoid itself. Start with the basic system checks, and if other codes are present, understand those first so you do not chase the wrong fault. Begin by reading DTCs and all ECUs with the scan tool. Record the codes and the related captured data, then save a vehicle scan report and the recorded data for later comparison. Erase the DTCs, turn the ignition off for a minimum of 10.0 seconds, then turn the ignition back on. Reproduce the operating conditions that set the code and read the DTCs again. The monitor runs with the engine running and battery voltage between 11.0 and 18.0 volts, so make sure the check is done under conditions that allow the fault to show itself. If P0013 does not return, handle it as an intermittent condition. If it does return, move on. Next, use the scan tool to run the exhaust facer 1 cleaning function. After that, check whether P0013 returns. If the code does not return, the repair is complete and the powertrain verification needs to be performed. If the code does return, continue into the circuit checks. With the ignition off, isolate the K442 VCT control circuit and check it for a short to another circuit at the PCM harness connector side. Disconnect the ECU and every component connector that contains the circuit being tested, while leaving the inline connectors connected for this part of the test. Use the wiring diagram to follow the circuit path. Connect one DVOM lead to the K442 circuit at the ECU harness connector, then use the other lead to probe the other circuits at that connector. Do not probe the PCM harness terminals directly. Use the GPEC diagnostic adapter 10436 when access at the PCM connector is needed. With the circuit isolated, there should be no continuity to any other circuit. If continuity is found, repair the short between the circuits that show continuity, using inline connectors to help narrow down the location, then verify the repair. If there is no continuity, continue. Now check the K442 VCT control circuit for an open or high resistance. Keep the ignition off for continuity testing. Isolate the circuit by disconnecting the ECU and the component connector for the circuit being tested. Before measuring the circuit, measure the resistance between the DVOM leads so you know what the leads are adding. Also remember that the GPEC diagnostic adapter can add up to 1.5 ohms of resistance to the circuit. Measure resistance from the component connector side of K442 to the same circuit at the GPEC adapter. The circuit should be below 3.0 ohms. If it is not below 3.0 ohms, repair the open or high resistance, then verify the repair. If it is below 3.0 ohms, continue. Next, isolate the K442 VCT control circuit and check it for a short to ground. The ignition must be off for this continuity to ground check. Disconnect the ECU and every component connector containing the circuit being tested. Put the negative DVOM lead on a known good ground. Then probe the K442 circuit at the component connector with the positive lead. There should be no continuity between ground and this circuit. If continuity to ground is present, repair the short to ground, using the wiring path and inline connectors to isolate where the short is, then verify the repair. If there is no continuity to ground, continue. After K442 passes, check the Z904 circuit for an open or high resistance. Keep the ignition off, isolate the circuit by disconnecting the ECU and the component connector, and account for DVOM lead resistance before measuring. Again, the GPEC diagnostic adapter can add up to 1.5 ohms of resistance to the circuit. Measure from the component connector side to the same circuit at the GPEC adapter. Resistance should be below 3.0 ohms. If it is not below 3.0 ohms, repair the open or high resistance and verify the repair. If it is below 3.0 ohms, move to the solenoid operation check. Reconnect the PCM-C2 harness connector and turn the ignition on. Measure voltage on the K442 VCT control circuit at the VCT solenoid harness connector. The VVT solenoid driver circuit is a 12-volt PWM circuit, so the voltage reading will vary with the actuation percentage selected for the solenoid. If voltage is present and it approximately matches the selected percentage, verify good pentaterminal contact at the VCT solenoid connector and the PCM connector. If no connector problem is found, replace the variable camshaft timing solenoid, then verify the repair. If the voltage is not present or does not match as expected, continue to the harness connection checks. For the final circuit side check, disconnect all PCM harness connectors, any related inline harness connectors if equipped, and the related component connectors. Inspect the harness and component connectors, including the male and female terminals. Look for connector installation problems, damaged locks, corrosion, water intrusion, weather seal damage, bent terminals, overheating from poor connection, terminals pushed back into the cavity, spread terminals, and poor terminal tension. Repair any condition you find. Then reconnect the PCM connectors, inline connectors if equipped, and related component connectors. Make sure every connector is fully seated and every lock is fully engaged. Erase the DTCs, test drive or operate the vehicle under the conditions that run the monitor, and read DTCs again. If P0013 returns after those connection checks, replace and program the PCM, then verify the repair. If it does not return, the wiring or poor connection problem has been repaired, and the repair still needs to be verified. Keep the verification separate from the testing. Anytime you repair a circuit fault, replace the VCT solenoid under the supported test result, or replace and program the PCM under the final supported test result. Run the powertrain verification and confirm the code stays gone. The takeaway is simple. For P0013, prove the fault is current, give the commanded cleaning routine a chance, then work the circuit in order, short to another circuit, open or high resistance, short to ground, ground circuit integrity, solenoid operation, connector integrity, and only then the PCM. For more diagnostic training, visit Diagnostics.com.